Dobar dan, dobroveče. Poštovani posetioci, hvala vam što ste došli u ovako velikom broju. Dobrodošli na tribinu u okviru ovog našeg specijalnog programa pod nazivom Prvi pogled u svemir, koja je, kao što znate, posvećena početku rada jedne vrlo specijalne observatorije, čije ćemo ime dugo spominjati, a to je ime slavne američke astronomkinje Vere Rubin. Podsjećam vas da današnji događaj zajednički organizuju dve naše najprestižnije astronomske institucije, Matematički fakultet Univerziteta u Beogradu i Astronomska Opservatorija u Beogradu, tu se može reći i najstarije institucije, zajedno sa Centrom za promociju nauke i naravno Domom omladine, u čijem smo ovom rashlađenom prostoru danas po ovom vrelom danu. Moram da kažem da je po svemu sudeći ovo najveći naučno-popularni događaj u ovoj neobičnoj godini u kojoj živimo, ali povod je zaista veliki jer ono čega ćemo biti svedoci večeras je verovatno i jedna od najvećih naučnih senzacija u ovoj godini. Moje ime je Slobodan Bubnjević i ja sam šef komunikacije u Institutu za fiziku u Beogradu. Biću domaćin večeras vam tokom ovog razgovora, a kao što je najavljeno, kao što znate, iako su neki nestrpljivci među nama već videli neke fotografije koje su snimljene na Opservatoriji Vera Rubin, moram da kažem da je to samo teaser onoga što ćemo imati prilike vidimo večeras. Za sat vremena nas očekuje uključenje u centralni događaj u Vašingtonu, u Američkoj akademiji nauka, kada ćemo videti stvarno prvi pogled Rubina u svemir i bit će prikazani neki snimci koje samo možemo da zamislimo šta. Dakle, to je samo za sat vremena. U međuvremenu porazgovarat ćemo s našim gostima večeras o tehnologijama koje su se morale spojiti da bi ovaj teleskop bio to što jeste, ali još važnije, pričat ćemo i o nauci koja će uz pomoć ovog instrumenta moći da se istražuje. Bez daljnjeg takođe osvrnut ćemo se i na zaista važan doprinos Republike Srbije i srpskih astronoma i astrofizičara koji su doprineli zapravo i instalaciji ovog postrojenja, ali takođe učestvuju u ovom naučnom delu. I na kraju ćemo da se osvrnemo i na velike mogućnosti koje ovaj instrument pruža za razvoj nauke i u našoj zemlji. Na samom početku, pre nego što predstavim naše goste, prosto imam ličnu potrebu da podsjetim na to da je ova fantastična instalacija dobila ime po astronomkinji Veri Rubin, ona je odigrala presudnu ulogu u razumevanju galaktičkih rotacija, gde je otkrila izvesna neslaganja, što je zapravo dovelo do tog zaključka koji danas uzimamo zdravo za gotovo, da postoji tamna materija. Kod njoj se puno govori o nauci i možda se i najmanje zna od fenomena koje imamo. Dakle, to sve ne bi bilo moguće bez doprinosa koji je dala naučnica po kojoj ovaj teleskop nosi ime. Ali nije ništa manje bitno da se tokom života doktorka Rubin zaista ne samo svojim ličnim primjerom, nego inače zalagala za podizanje uloge žene u nauci i zaista odluka da ovaj teleskop nosi njeno ime pravi omaž naporu tolikog broja naučnica koje svakodnevno doprinose nauci, a nisu dovoljno vidljive. I sad mi dozvolite da predstavim naše večerašnje goste. Pored mene je kolega Zoran Tomić, savjetnik ministra za interresornu saradnju u Ministarstvu nauke, tehnološkog razvoja i inovacija. Zorane, dobrodošli. Uz njega je gospođa Medlin Mahon, ataše za kulturu u ambasadi Sjedinjenih Američkih Država u Beogradu. Mrs. Mahon, thank you for being with us tonight. Pored nje je Luka Popović, direktor Astronomske observatorije i rukovodilac srpskog naučnog doprinosa Vera Rubin observatoriji. Hvala vam što ste tu sa nama. Onda zatim Anđelka Kovačević, profesor na Matematičkom fakultetu i rukovodilac srpskog doprinosa, direktabilnog softverskog doprinosa Vera Rubin Opservatoriji i na kraju ovog niza Dragana Ilić, profesorka na Matematičkom fakultetu i menadžerka projekta Srpskog naučnog doprinosa Vera Rubin Opservatoriji. I molim vas da jednim aplauzom pozdravimo naše goste. Šta je Opservatorija Rubin? Mnogi znaju u publici, a neki se možda još malo i pitaju, a i oni koji znaju, kao što smo vidjeli malo čas, ne mogu znati sve o tome. Hajde da pogledamo jedan od mnogih, stvarno mnogih video snimaka, video priloga koji su pripremljeni sa ciljem da odgovore na to pitanje šta je Opservatorija Rubin.
Our story today starts in the late 1990s, when the idea for what would become the Vera C. Rubin Observatory started to emerge. At the time, researchers were looking for ways to explore dark matter. Dark matter is a substance that only interacts with ordinary matter, like the matter here on Earth, gravitationally. As researchers were trying to find new ways to explore dark matter, they made observations of supernova explosions that hinted that the expansion of the universe is actually accelerating. These observations implied the existence of a mysterious dark energy that permeates all of space. If we take all the forces that shaped the universe, scientists currently believe that the universe is made up of about 5% ordinary matter, 27% dark matter, and 68% dark energy. In this case, the term dark applies because it doesn't appear to emit, reflect, or absorb light, and scientists aren't yet sure about how to directly detect it. In order to get some more insights into dark energy and dark matter, astrophysicists realized that they would need to map out the large-scale structure of the universe and its changes over time. Where were they going to start? In 2003, Steve Kahn, an astrophysicist working on the subject, joined SLAC. He brought with him the idea that SLAC and the Department of Energies should engage in the development of a large aperture wide-field telescope that could probe at the very nature of dark energy and dark matter. Along with his fellow researchers, Kahn spent the next decade building out an international network of scientists and researchers to begin working on how they could bring the telescope to life. While the telescope itself is being built in Chile, the centerpiece camera module is being assembled right here at SLAC, using parts developed at SLAC and at other institutions around the world. As you can see from this map, the coordinated effort it took to bring together so many widespread teams was an enormous feat. The centerpiece of the telescope would be its camera module. In the early 2010s, after all their preparation, SLAC researchers and their collaborators in the US and in Europe began prototyping the camera. The camera was designed with a sensor of 3,200 megapixels, making it the largest camera ever built for astronomy. For comparison, the smartphone you might be watching this on right now probably has around 12 megapixels. Using this powerful new camera, researchers plan to capture one image every 30 seconds. Now, I know that may not sound very fast, but remember they're photographing into deep darkness. They need a longer shutter speed for this. Once they have all these images, scientists will produce a very high-resolution image of the southern sky every 3 nights. Ultimately, the plan is to run it as a 10-year project. That means that over the course of those 10 years, the camera will capture the entire southern sky over 1,000 times. This process will create a detailed map of the night sky, revealing how matter is distributed throughout the universe, as well as charting changes in the sky and matter over time. These observations will help researchers understand the nature of dark matter and dark energy. But that's not all. The telescope and its camera will help astronomers map out a lot of transient phenomena, like exploding stars and asteroids whose positions change from night to night. A helpful way to think of it is kind of like a 10-year-long movie of the universe. This 10-year survey is called the Legacy Survey of Space and Time. or LSST. And the camera module itself has come to be known as the LSST camera. In order to design electronics for the new detectors, LSST camera researchers collaborated with teams at SLAC and at the Department of Energy's Brookhaven National Lab. They also worked closely with the Department of Energy's Lawrence Livermore National Lab to develop some of the largest camera lenses ever built. Now, after 2 decades of work, the LSST camera is complete. Then, it'll be shipped to Chile and finally ready to take the most detailed images of the night sky ever produced. If all goes according to plan, that'll happen sometime in 2024. Over its 10-year run, the LSST camera and the Vera Rubin Observatory are going to have a huge impact on the field of astronomy by cataloging roughly 20 billion galaxies. That's around 10% of all galaxies estimated to exist in our observable universe. And no one knows for sure what we'll discover, but it's a really exciting time for astronomy. And we're glad you're on this journey with us now. To learn more about SLAC, check out our other videos in our history series, as well as our explainer videos that give more insight into the science. And please subscribe. You can also follow us on Instagram, Twitter, Facebook, and
Znači, ovi napori koji su pomenuti u ovom videu su se ostvarili i danas ćemo vidjeti snimke koji su nagoveštavani, možda s godinom zakašnjenja odnosno na ono što je bila predikcija iz videa. Zorane, recite nam po vašem mišljenju koji je značaj učešća jedne relativno male zemlje, iako ona ima vrlo dinamičnu astronomsku i astrofizičarsku zajednicu, koji je značaj učešća na nivou celog naučnog sektora za razvoj nauke u jednom ovakvom projektu kao što je Rubin Opservatorija?
Prvo da vas sve pozdravim i da kažem da je zaista velika čast biti danas ovde sa vama u ovom istorijskom trenutku. Ovo jeste jedan od istorijskih projekata koji smo dugo čekali i zaista je za ponos videti sva ona imena naših astrofizičara koji su dali u ovoj fazi doprinos, a taj spisak će svakako biti još mnogo veći kako projekat se bude sprovodi u narednih 10 godina. Svakako da je značajno jer je i to realizacija nekog 10-godišnjeg plana kada je u pitanju ta posmatračka astronomija u Srbiji. Znamo da sada kao astronomska zajednica radimo na razvoju nove strategije, novog 10-godišnjeg plana i svakako da ta kolaboracija koja će u narednom periodu se sprovoditi je značajna i zbog toga što, kao što ste i rekli, jesmo mala zemlja, ali zaista imamo veliku astronomsku zajednicu, puno astronoma amatera i potencijalnih profesionalnih astrofizičara koje na ovaj način možemo privući. A i takođe je značajno jer kao zemlja se vraćamo u Kopus, u Komitet za mirnodopsko korišćenje svemira. Nažalost, nećemo završiti to ove godine, ali u narednoj da. I imat ćemo tu dosta posla jer jedna od opasnosti za ovaj projekat jeste to što noćno nebo znate da nije baš toliko ni tamno ni tiho i kao država ćemo se u Kopusu zalagati da očuvamo tamno i tiho noćno nebo koje je važno da bismo ove istraživanja sprovodili i kao ministarstvo i država daćemo maksimalnu podršku Astronomskoj observatoriji Beograd i Matematičkom fakultetu u realizaciji, pre svega jer imamo sjajnu astronomsku stanicu Vidojevica o kojoj nažalost nismo pričali toliko, ali ćemo raditi na njenom promovisanju i pomoći da se dođe do nove tehnologije koja je svakako bitna jer ćemo čuti od govornika zašto je ta astronomska stanica Vidojevica važan segment u ovom projektu.
Hvala mnogo, Zorane. Mrs. Mahon, in your view, how do high-tech scientific facilities like Rubin Observatory contribute to cultural paradigm shifts?
Hi, everyone. Thanks for the question. I also just want to say thanks for having me. This is really an exciting event to be at. I was looking at the pictures earlier today. They're so beautiful. You know, I think I am not a scientist, right? And probably many of you aren't scientists. I think that's kind of a testament to the way that we can't separate science and culture. It's part of all of our lives. And things like the Rubin Observatory on a really basic, just technical level. I mean, think about all of you are using your phones, you have cameras. The cameras in those phones were originally the technology developed by astronomers. This is going to be one of the biggest digital camera in the world. And that technology came about and was being used for astronomy, and then eventually in your cell phones, in movie making, in medical imagery. I mean, science influences culture in our daily lives left and right. I think also the thing that I love about stuff like this is it's really about the democratization of information. So for those of us who aren't scientists, 100 years ago, 200 years ago, knowing about the things happening in space, dark matter, planets, energy, might be sort of a philosophical idea, but you couldn't really grasp it, you couldn't see the pictures. But with things like this observatory, everyday people have a chance to see this kind of beautiful scientific imagery, and maybe that inspires the next generation of students to become astronomers, to become scientists. So this kind of sharing of information on a large scale, I think is really, really important just in the way we think about what's possible for our future, what we're interested in, and really, I hope will shape the next generation of people, not just in Serbia or the US, but all around the world.
Thank you. Are you personally surprised that so many people in Belgrade are so interested in science? When you look in this
I mean, I
hall?
think it's amazing to see this many people at an event on a Monday afternoon, a hot Monday afternoon. But I don't think I'm necessarily surprised. I mean, I think there's something about space exploration and space discovery that is so inspiring, so thrilling for everyone. I mean, again, I'm not a scientist, but I grew up, you know, as a kid in my backyard with a telescope looking at stars. I have a young son, and we have like all the planets on his ceilings that he looks at every night. I mean, there's something about this idea of the other, this world that feels like we can't quite explore, but we're just starting to learn about it, that I think everyone in Serbia, in Belgrade, in the world can sort of find hope in and excitement and, I don't know, look for something better.
Okay, thank you very much. Mi smo imali prilike da vidimo na početku kako je izgledala cela ta operacija, ali neki fascinantni detalji vezani za ovu, ajde kažemo, novu tehnološku paradigmu snimanja sa svemira zaista vrede da se pogledaju pre nego što vidimo njene rezultate. Predlažem da pogledamo dva videa, relativno su kratki. Dakle, jedan nam pokazuje sklapanje kamere, a drugi njenu instalaciju, i to je ono što će nam pomoći posle da dođemo do snimaka koji će biti za sada sve manje od sat vremena.
Ja ću samo, ako mi dozvolite, da komentarišem malo ovaj video koji pokazuje zapravo kako se zapravo prave dimenzije LSST kamere, koja definitivno pomera granice svega što smo mi, kako smo zamišljali teleskope do sada. Ovo je zapravo trenutak kada se ta velika LSST kamera diže na platformu gde se nalazi i teleskop, i ono što je zaista vrlo impresivno, ne samo naravno te dimenzije koje su i cela, da kažemo, konstrukcija, i za ono što ovim videom želimo da pokažemo, da ta naša slika klasičnog nekog teleskopa i instrumentarijuma je potpuno promenjena. videli ste možda ilustracije uopšte kako zamišljamo mi, kako izgleda teleskop. To je sada jedan vrlo moćan sistem koji je vrlo brz i kompaktan i zaista nikako ne podsjeća na neki klasičan teleskop, optički teleskop recimo koji su možda neki od vas imali prilike da vide na Astronomskoj opservatoriji u Beogradu, gde možete da nas posjetite svakako jednomesečno da vidite te klasične videe. Hvala.
Hvala Dragana mnogo. Da, zaista izgleda bitno drugačije od običnog teleskopa, to verovatno svi mislite, ali lepo što nam je Dragana na to ukazala. Luka, recite nam, dakle, iz prosto vaše perspektive, dakle, od ozgo sa Zvezdare, dakle, koje biste, ali mogu da kažem i sa Vidojevice, koje biste momente u užem smislu istakli koji su od značaja za razvoj domaće astronomije u pogledu korišćenja jednog ovakvog instrumenta kao što je Opservatorija Rubin?
Ja prvo moram da kažem da neke benefite ili koristi smo već imali. Ne bi se vraćao u 2007. godinu, ali bi se vratio 10 godina unazad kad smo prvi put čuli za projekat i to od relevantnih ljudi koji su bili uključeni u sam projekat. Mi smo, da kažem, jedni od prvih, Srpska astronomska zajednica je jedna od prvih koje se pridružila tom projektu i veoma je interesantno kada je projekat predlagan NSF-u da bude finansiran. Dve države su se pojavile, pošto je bilo pitanje da li ima zainteresovanih drugih država, pojavile su se dve države, to je Francuska i Srbija. Tako da smo mi od samog početka u tom projektu. Sad, koje smo benefite imali? Pre svega, naši timovi su aktivno bili uključeni u različite segmente, od slanja alerata do razrade softvera, do toga da organizujemo posmatranja na Vidojevici. Znači, to je, kako da kažem, veoma bitno za jednu zajednicu da bude uključena u tako veliki projekat koji je ne samo veliki po sredstvima, nego veliki po kapacitetu ljudi koji učestvuju od različitih država. Znači, to su jedni benefiti. Između ostalog, druga konferencija LSST at Europe bila je održana u Beogradu 2016. godine. Ne prva, već druga. I tu smo sreli dosta kolega, tu smo diskutovali na samom početku ovog projekta. Međutim, kako se projekat ubrzavao, zahuktavao, dolazio do realizacije, sve više smo ulazili sa nekim pitanjima koji su konkretni. Od toga kako pripremiti naš teleskop od 1,4 metra, kako razviti softver, kako učestvovati na kraju krajeva u jednom konzorcijumu koji sad, ruku na srce, više liči na neki konzorcijum velike kompanije, nego što smo mi naučili astronomi. Recimo, meni to malo, pošto sam ja astronom starije kova, malo i ne prija, ali u svakom slučaju mi smo uspeli da uđemo, kako da kažem, u taj prvi tim i sama ova prezentacija pokazuje da smo u tom timu i velika je radost da ćemo učestvovati u samom početku i ovaj veliki dan kad na kraju počinje da se ostvaruje taj veliki projekat. Ja moram da pomenem da mi je žao što neki ljudi koji su radili kao dr. Darko Jevremović na ovom projektu nisu dočekali da taj projekat počne, no nadamo se, i to ćemo danas videti, ja sam već video, ne samo lepe slike, nego to je onaj budući benefit koji ćemo imati, a to je imat ćemo, što kažu, vasionu u tanjiru. Hvala vam.
Hvala mnogo. Tako, iz jedne, ajde kažemo, naučno-fantastične perspektive, dakle, ako bi neko hteo, kad mi snimamo svim našim teleskopima noćno nebo, da se sakrije, dakle, uvijek je do sada mogao da se sakrije, dakle, ali posle Rubin observatorije i njenog delovanja, dakle, nemate gde više da se sklonite, dakle, ona sve vidi, bar na južnoj hemisferi. Sad, tome jako doprinosi softver koji vozi celu ovu stvar i Anđelka, koje softverske inovacije je srpski tim doneo i donosi u Rubin observatoriju i kako to zapravo doprinosi nauci koju će ova observatorija omogućiti?
Dobar dan svima, još
jednom. Samo malo bliže mi.
Veliko hvala, posebno našim gostima i Veri C. Rubin observatoriji. Sa njome mi smo zaista zakoračili u novo vreme, u novi vek i ako možete zamisliti astronome koji su nekada posvećivali ceo život izučavanju jedno-dva objekta, mi se susrećemo sada sa milionima i milijardama objekata i u takvom periodu neophodna je primjena veoma složenih naučnih oruđa. Što se tiče našeg tima, mi proizvodimo i želimo da razvijamo dalje u saradnji sa kolegama sa Katedre za informatiku Matematičkog fakulteta, pre svega profesorom Mladenom Nikolićem i timom sa Fakulteta organizacionih nauka pod rukovodstvom profesora Vladana Devedžića, algoritme koji će zapravo pomoći nam u takozvanoj astronomskoj tomografiji. Da od podataka koje dobijamo iz optičkog domena, koje izgledaju kao promjena sjaja objekata u 1D dimenziji, da dobijemo informacije možda o tome kako izgleda okolina tog objekta u 3D. I takvi algoritmi imaju veliku primjenu i u medicini, kao što je gospođa Madeline Mahon pomenula, i posebno mi je drago i čast da ovde u publici imamo posetioci iz budućnosti, to su mladi naraštaj i verujemo da će oni se pridružiti ovom projektu. Hvala puno.
Hvala mnogo. Dragana, da li biste mogli da nam date jednu vrstu projekcije? Dakle, kakav dugoročni uticaj očekujete da će Rubin imati na naučnu zajednicu u Srbiji i regionu? U naučno-popularnom smislu vidimo da su efekti već postoje, dakle, okupljaju se ljudi oko same ove ideje. Dakle, kako to može zapravo da transformiše i samu nauku u Srbiji?
Hvala najlepše. Ja bih takođe da pozdravim publiku. Zaista smo vam beskrajno zahvalni što ste danas svi ovde sa nama da proslavimo zajedno ovaj veliki trenutak za nas. Mi smo ovo iščekivali zaista godinama, verujte nam. I ponosni smo da budemo deo ovog tima. Beskrajno smo zahvalni Rubin observatoriji na ovoj prilici da sa svojom ekspertizom obezbedimo mesto srpskoj nauci u jednom ovako svetskom projektu. I zaista moram da kažem da mi sada trenutno otvaramo nova vrata istraživanja astronomiji. Mi ćemo sa ovim projektom Legacy Survey in Space and Time Rubin observatorije snimiti do sada najveći broj asteroida i malih tela u sunčevom sistemu, najveći broj zvezda u našoj galaksiji i najveći broj drugih galaksija, koji će nam pomoći da odgovorimo na 4 vrlo važna naučna cilja. To je nezamislivo. Nezamislivo je nama astronomima, kamoli opštoj, da kažemo, zajednici i svima koji ste ovde danas. Mi ne možemo sami da ispitamo sve te podatke i nama je neophodna sinergija sa drugim institucijama, znači ne samo astronomskim institucijama, ovde pre svega mislim nekako prirodno sa našim matematičkim fakultetom, sa matematičkim institutom, sa fakultetom organizacionih nauka, mašinskim fakultetom, ETF-om, drugim institucijama i šire. Znači, ta prilika da se sve naučne institucije u Srbiji povežu oko ovog projekta je zaista tu. I to je nešto što se mi nadamo da će se desiti, da će to biti možda najveći uticaj koji ćemo ostaviti na naučnu zajednicu u Srbiji, jer ono što mi dobijamo sada u ovom prvom trenutku, u prvoj fazi i prvim podacima, već sada od 30. juna dolazi nam, da kažemo, preliminarni podaci. Mi imamo ekskluzivan pristup ovim podacima da dođemo do revolucionarnih istraživanja i revolucionarnih rezultata koji će odjeknuti u široj svetskoj naučnoj zajednici u sledećih 1.5 godina, a i kasnije, zato što se pripremamo već deceniju na ove podatke, moći ćemo da obučimo druge ljude, da uključimo i građanstvo, jer to, da kažemo, ta građanska nauka je veliki edukacija i obrazovanje je veliki cilj Rubin Opservatorije i ta demokratizacija koja je već sada bila pomenjena. Tako da, samo ću još na kraju reći da posebno algoritmi koji se razvijaju, pošto su bazirani na podacima, bazirani su na mašinskom učenju, na budućoj veštačkoj inteligenciji, definitivno nalaze primjenu na drugim podacima i to je neka sad isto sinergija koju vidimo sa industrijom u Srbiji i gde se nadamo da ćemo sa ovim projektom otvoriti vrata i ka tome.
Hvala mnogo. Sad, pošto nije to tako česta prilika da na sceni u Beogradu imamo, mada su događaji svuda, ali da na sceni imamo 4 astronoma, pa bih ja ipak, iako to nije u scenariju, postavio za astronomski deo večerašnjih gostiju pitanje, dakle, zvezde posmatračke astronomije poslednjih decenija su ipak svemirski teleskopi bili, to se verovatno slažete sa mnom, i sada se situacija malo menja, bar u popularnosti u ovom trenutku. Šta je vaš utisak, ako možete kratko svi da mi kažete, vaš lični doživljaj, po čemu je ovo bolje i drugačije za vas lično od svih instrumenta koje smo ranije imali, neobavezno svemirskih?
Ja ću početi, ali koleginice će me dopuniti, sigurno.
Možete početi, Luka, izvolite.
Postoji razlika kad posmatrate određen objekat, onda vam je potrebno, znači atmosfera, moramo nešto da dišemo, naravno, i koristi nam, nemamo upade jakih zraka, štetnih uticaja zraka, međutim, ona nam smeta. I najbolje je ovaj ili ovakve teleskope izmestiti izvan atmosfere. Međutim, ovako kompleksan teleskop sa ovolikom kamerom, videli ste kolika je kamera, to bi zahtevalo izuzetne uslove. To može, eventualno, kad smo pričali nešto, pa sam se ja malo šalio sa svojim kolegama, ja kažem što ovaj teleskop ne postavite na mesec, gde je manja atmosfera. Međutim, kako da kažem, i jedni i drugi teleskopi imaju svoju svrhu, ali ovo je posebno značajan zato što će on najdublje da gleda u vasionu i da ulovi te slabe objekte u vasioni. Ono što sam rekao, imat ćemo vasionu na tanjiru, znači kad dobijemo jedan snimak, vi možete da birate sa tog snimka hoćete li da izučavate asteroide, zvezde, eventualno planete koje možda sad i ne vidimo, ili ćete raditi to sa galaksijama, gravitacionim sočivima, nekim lukovima koji su neprimećeni, inače sad kad posmatramo i sa ovim kosmičkim teleskopima, znači imat ćete jednu celu lepezu i zato je on izuzetno, kako da kažem, on nije najveći teleskop, znači nije ni najveći. Ima i većih teleskopa, ali tehnički i tehnološki je veoma unapređen i to mogu da tvrdim kao astronom, ono što bi trebali da vidimo za sad je najbolje u tom smislu.
Ja bih samo rekla da zaista moja ljubav prema teleskopima je beskrajna, a svemirski teleskopi nemaju premca. Znači, nemaju Gaia misija, James Webb, Hubble, koji i dalje radi fenomenalno i daje rezultate. To su spektakularne misije, ali one se ipak nalaze u svemiru. Mi ovde na Zemlji sada imamo priliku da sa istim kvalitetom, kao što su to svemirski teleskopi, postignemo nekoliko veličina više u smislu broja objekata, detalja i slično. I ne samo to, ono što nekako možda nismo dovoljno istakli, ovaj nam teleskop daje tu mogućnost, tu vremensku dimenziju, jer ćemo mi proizvesti taj digitalni 10-godišnji film celog univerzuma koji se vidi sa Zemlje do dubine, odnosno do osetljivosti svemirskih teleskopa, što nikako ne bismo mogli da postignemo sa tim teleskopom. Tako da, budite spremni.
Dobro, evo još jedno pitanje vezano za astronomiju. Možda će Anđelka htjeti...
Da kažem, što se mene tiče, Hubble Space Teleskop, izvanredan instrument, ali uperite ga u jedan objekat, aplicirate za vreme. U ovom smislu, znači LSST će hvatati milione objekata i jedan sličan instrument, ali u svemiru, jeste i Euclid, Space Observatorij, sa kojom će LSST imati veliku sinergiju podataka.
Zoran, izvolite.
Evo ja samo da dodam, ja sam astronom amater, zapravo po profesiji sam ekonomista, ali sa ekonomske tačke gledišta je svakako mnogo racionalnije kada imate opremu koja je na zemlji zbog njenog održavanja i produžetka životnog veka. Svi se sećamo Hubble-a kako je prošao kada je lansiran i koliko je koštala njegova opravka, a sa druge strane ovo je zaista velika šansa u smislu promocije nauke, jer smo navikli nekako na astronomiju iz fotelje i da sve radimo iz fotelje preko telefona i slično. Ovo je jedna lepa prilika da se malo podsjetimo onih starih teleskopa kako funkcionišu, da izađemo na livadu pod mračnim nebom i da uživamo prosto u toj vizualnoj astronomiji. A i ono što je bitno da se naglasi, što je Luka rekao, i Vidojevica će imati svakako značajan uticaj na ovaj projekat, jer kako će Rubin skenirati, tako će pojedine observatorije dobijati zadatke šta od fenomena dalje da prate. A tu je onda dalje i posao za astronome amatere, koji, hvala Bogu, imamo dosta u Srbiji i veliki broj tih amaterskih observatorija, koji uopšte ne deluju amaterski, koje su i tekako profesionalne, gde će biti i za njih prostora da se uključe u ovakve aktivnosti, tako da eto jedna lepa prilika da dokažemo zašto je astronomija ne samo romantična nauka, već i jedna od najboljih nauka u kojima mlade ljude možete da zainteresujete da se bave astronomijom, iako se odluče da budu sutradan ekonomisti kao ja.
I just add one thing to that as well. I think that was really beautifully put. But that also we have the ability for this new information to impact culture in so many ways, to change the way movies talk about space and science, to change the way literature talks about space and science. And I think when you have one of these really big new discoveries in a new generation, it's going to inspire people not just to go out in their backyards and look through telescopes, but to think about space differently, to think about our place in the world differently, to think about humanity differently. And that's a really incredible opportunity that only really can come around with these huge advances in science.
Thank you very much. Dakle, svi su rekli reč inspiracija, ali ajmo samo malo da se sad pozabavimo pitanjem kako to Opservatorija Rubin skuplja svetlost i snima celo nebo za samo par noći. To ćemo vidjeti u jednom klipu koji je kratak, a nakon toga je malo duži o problemu Big Data, dakle o velikim podacima i o nauci za sve. Dakle, da pogledamo dva videa koje nam objašnjavaju te dve stvari iz te neke drugačije perspektive.
How does Rubin Observatory collect so much light and move so fast? We combined two different mirrors on a single surface to make Rubin's unique 8.4 meter mirror. Light hits the outer surface first, bounces up to a 3.4 meter secondary mirror, back down to the 5 meter inner surface, and then up to the camera. This mirror design gives Rubin enormous light collecting power, but also keeps it compact and nimble so it can cover the whole visible sky in just a few nights.
Wouldn't it be awesome to help discover something totally new in space? Throughout history, telescopes have helped us explore the universe from right here on Earth. But not everyone has access to telescopes or the data they produce. Wouldn't it be better if we could all participate? Rubin Observatory thinks so, and that's why it makes more data available to more people than ever before. Not just scientists, but you too. How does Rubin Observatory turn light from space into data we can all explore? Come with us and find out. First, we go to Chile, where Rubin Observatory takes huge pictures of space from high on a mountain. But these pictures are so big that you'd need 378 4K television screens to view just one. That's not a practical way to do astronomy. So instead, the camera converts light from space into data and pushes the data out into the night. The data slide down the mountain on high-speed fiber optic cables. Then they zip along other cables that take them to the United States by land and under the sea. the data are processed and cleaned up at supercomputing centers in the US and in other places around the world. Once they're the most useful they can be for astronomy, Rubin Observatory releases them to scientists. In the past, researchers needed expensive computers and software to analyze astronomy data, but they can work with Rubin data using just an internet browser. That means more scientists can participate in astronomy than ever before. But Rubin Observatory wants to make space exciting for everyone, whether you're a trained scientist or just someone who thinks science is cool. So, we built a website where you can explore stunning images and exciting new stories about the universe, and even contribute to real, cutting-edge astronomy research. What will you discover?
Ostalo nam je još 10 minuta do onog što znate da je najavljeno, dakle tog glavnog uključenja u Američku akademiju nauka u Vašingtonu, ali sad imamo za vas nešto što niste možda očekivali, dakle, i ne znam da li drugi watch party imaju tu mogućnost, dakle, sada ćemo se uživo uključiti i razgovarati sa doktorkom Marinom Pavlović, koja je član tima Opservatorije Rubin, dakle, idemo na lice mesta u pravom smislu te reči, i nadam se da će tehnika uspeti da nas poveže. Dakle, ovo je sad samo zemaljska komunikacija. Marina, dobro večer. Ovde te pozdravlja puna sala Doma omladine.
Dobro večer, kako ste? A kod mene je još jutro. Jel me čujete?
Čujemo te sjajno. Reci nam prvo, kakav je tvoj doživljaj ove situacije sad kad ulazimo u veliko finale?
Joj, mi smo preuzbuđeni već neko vreme, teleskop radi još od aprila, gledamo slike svaki dan, ali znaš kao to su neobrađene slike, to su slike direktno sa kamere i prvi put smo i mi danas videli prve slike Rubina, prve obrađene slike, ono što zapravo čekamo i toliko je uzbudljivo, toliko su svi ljudi nekako srećni. Jako malo ljudi je trenutno na observatoriji, svi su dole u La Sereni za slavlje i za medije, a samo par nas je trenutno ovde, tako da pokušavamo da vam prenesemo atmosferu odavde. Ja se trenutno nalazim na Rubin observatoriji na 8. nivou gde se zapravo nalazi teleskop koji možete videti iza mene.
Aplauzi.
Malo je teško, ne znam da li mogu samo da okrenem kameru na Zoomu, ne mogu. Ne mogu, nažalost, ali evo pričat ću malo bliže, tako da ako imate bilo kakvih pitanja, slobodno pitajte. Mi smo ovde, znači, imamo par medija, tako da ćete možda čuti i druge live streamove pored mene. I trenutno je teleskop na horizontu i spremni smo da vam pokažemo ogledalo. Ovo plavo što vidite ovde, zelenkasto plavo, je zapravo filter na kameri koji se vidi u samom ogledalu i to je air filter trenutno. Postoji šansa da će se promeniti u svakom momentu, tako da pratite taj deo.
Dobro, Marina, reci nam, dakle, teleskop je na velikoj nadmorskoj visini. Kako je raditi tu, biti istraživač na toj lokaciji?
Da, jako je teško. Mislim da je to najteža stvar zapravo. Baš sam sad išla, pošto je teleskop cela observatorija je na 9 spratova, jako je teško penjati se u stepenice, tako da uvek koristimo lift kad god možemo i mnogo je teško da se spava ovde zato što je usred atakame i vazduh je mnogo suv. Tako da suv vazduh i visoka nadmorska visina, to je nekako najteže i prvi dan nam uvek najteže padne, meni je danas prvi dan, tako da osjeti se malo vrtoglavica, tako ti neki simptomi, ali nakon 2 dana ako ništa, kod nas smo kući, tako da nije toliko strašno, nekako je više zadovoljstvo biti i raditi na ovom teleskopu. Ja za to moram da kažem, eto, hvala i Luki, i Dragani, i Anđelki. Bez njih se ništa od ovoga ne bi desilo. Kao moj prvi postdoc, ja sam radila kao in-kind tim iz Srbije i to mi je zapravo omogućilo i da upoznam ljude ovde i da dođem ovde, a evo i da ostanem ovde. Tako da veliki pozdrav, svi mi nedostajete, vidimo se uskoro.
Marina, svi te pozdravljaju ovde. Reci nam samo koja bi poruka bila za mlade istraživače, dakle, koji bi eventualno želeli da slede tvoj put. Tebi je to sad relativno skoro. Dakle, kako stići do Rubin observatorije?
Pa ja mislim da nauka u Srbiji generalno na veoma dobrom putu, pogotovo sa ovim in-kind projektima i sa tim međunarodnim projektima, sa velikim observatorijama. I uglavnom budite uporni, volite to što radite, to sam ja uradila i evo sad gde sam, ali morate se uključiti, a mislim da je ceo in-kind tim iz Srbije veoma otvoren za saradnju, tako da ako želite da dođete, mislim ne samo ovde, i na drugim observatorijama, prosto pitajte ljude, pitajte Draganu, ja to uvek svima kažem, pitajte Draganu, ona zna sve.
Dobro. Imate li vi pitanja nekih za Marinu od naših astronoma ovde na sceni? Aha, da, ovde sufliraju da nam pokažeš kameru.
Jel možeš da ponoviš, izvini?
Da nam pokažeš kameru, ako je moguće.
Ovo je pozadina od kamere, ovaj crni deo. U tom crnom delu nalazi se svi kablovi koji povezuju elektroniku kamere sa samom kamerom. Ovde se nalazi reflektor na kameri i sad jako je teško videti je pošto je teleskop na horizontu, ali ja ću se potruditi maksimalno. Znači, ovo, nisam sigurna šta vidite. Ovo ovde je pozadina od kamere i ona se pruža skroz do kraja, do ovde. Ovo je sekundarno ogledalo, ovde možete videti odsjaj, ovo je primarno ogledalo od teleskopa. Ja se nadam da ste uspeli da vidite.
Jesmo, sjajno, hvala ti mnogo. Marina, zaista hvala ti mnogo na ovom uključenju. Nama se približava kao i tebi i svima, dakle, za koji minut uključenje u glavni događaj. Ostajemo na vezi i veliki pozdrav iz Beograda za Čile.
Hvala puno, veliki pozdrav iz Čilea, ćao!
Blizu je, dakle, uskoro ćemo da se uključimo, ali nekako u 3 minuta može još malo astronomije, dakle, pre nego što počnemo. Dakle, Dragana, pošto je rekla Marina kako sve tebe možemo da pitamo, pa će ići pitanje ka tebi. David Attenborough je u jednom velikom dokumentarcu o evoluciji života na Zemlji podsjetio nas na jednu čuvenu astronomsku fotografiju i o njoj se inače dosta u istoriji astronomije govori, to je ona plavi kliker fotografija Zemlje, ali u mnogim knjigama, pa i u tom dokumentarcu se govori o tome da je objavljivanje te fotografije za milione ljudi tada na Zemlji promenilo percepciju planete na kojoj živimo i da su vidjeli kako mi živimo na jednom zapravo rajskom mestu. Dakle, da li je previše smelo reći da će neki od snimaka koje nam Rubin observatorija napravi, dakle, na sinoptički način da vidimo, dakle, Univerzum na svim stranama odjednom, dakle, da li će to možda za obične ljude, za sve nas i naravno pre svega za ljubitelja astronomije, promeniti način na koji mislimo i vidimo svemir?
To je svakako očekivanje Rubin observatorije i celog tima da ćemo promeniti kako vidimo svet i šta su osnovni konstituenti univerzuma. Nismo pomenuli, nismo se dotakli toga. Jedan od prvog i ključnog naučnog cilja jeste zapravo davanje novih karakteristika jedne velike nepoznanice o astronomiji i fizici danas, a to je šta je to zapravo tamna materija i šta je tamna energija. To je, ovako malo smo se samo dotakli toga, to je jedan od, da kažemo, prvih i ključnih naučnih ciljeva observatorije, tako da to su nam zaista prva očekivanja koje će nam otvoriti. Možda nam neće dati novi prikaz naše planete, ali definitivno to je jedan od odgovora za kojim tragamo. I baš zbog toga smo i nazvali ovaj teleskop i posvetili ga Vera Rubin, koja je jedna od, da kažemo, pionirki u tim istraživanjima nevidljive materije. Možda ćemo pokazati da zapravo nevidljiva materija nam i nije ni potrebna, možda ćemo razviti neke nove teorije, možda ćemo dobiti neka nova inovativne rešenja uopšte tih problema na koje nalazimo u astronomiji i uopšte u posmatranjima, u podacima, ali to je ono što će nam ovaj teleskop omogućiti, daće nam pristup podacima, ekskluzivne, vrhunske podatke, ne samo naučnicima koji su radili na razvoju, već celoj naučnoj zajednici i građanskoj nauci i pozvati nas da svi dajemo ideje i predloge kako bismo mogli da objasnimo te podatke. Jer zapravo ono što je jako važno da mi uopšte sva naučna istraživanja i sve hipoteze potvrđujemo zaista posmatranjem i astronomskim podacima.
Hvala mnogo. Ostalo nam je vrlo malo vremena, dakle sad ćemo da idemo na glavni event. Ja vas molim da jednim aplauzom naše večerašnje učesnike pozdravimo. Hvala mnogo. Ja bih dodao, ajde da pozdravimo i ljubitelje astronomije u Beogradu, sve vas večeras koji ste ovde. I samo da kažem na kraju ono što uvek kažem na ovim događajima, pa shvatite kako god, nauka će pobediti. Silazimo sa scene, uključujemo se u Američku akademiju nauka.
High in the mountains of Chile lies the largest digital camera ever built. Named after the mother of dark matter. Tasked with filming the largest astronomical movie ever, observing across space and time. Bringing the night sky to life. The universe awaits.
Welcome, welcome. On behalf of my colleagues at the National Science Foundation and the Department of Energy's Office of Science, I welcome everybody here and all those streaming online. This day marks a very special occasion, revealing and celebrating the first look at the universe through the eyes of NSF DOE Vera C. Rubin Observatory. As we begin to bring online the top-ranked priority for ground-based astronomy in the National Academy's 2010 Decadal Survey. We trust that you will enjoy this tiny peek at the many discoveries to come, and we are very excited to show you. I am Edward Ajar, the NSF Program Director for Rubin Observatory. Before we begin, I would like to thank the National Academies for providing this beautiful venue and excellent support for this occasion. And now, it is my pleasure and honor to introduce to you Brian Stone, NSF Chief of Staff, performing the duties of the NSF Director. Please welcome Brian Stone.
Thank you, Ed, and thank you to all of you for being here today. Starting today, our ability to understand dark matter, dark energy, and planetary defense will grow even faster than ever before. This exciting new future is thanks to the vision, work, and support of the many people we're proud to recognize here today. Let me begin by thanking the White House Office of Science and Technology Policy Director, Michael Kratsios, and the administration for their continued support of exploratory science. By working across federal agencies, OSTP, NSF, DOE, we turned shared investment and coordination into a transformative interagency public-private partnership. The flagship observatory has been more than 20 years in the making, with NSF behind the project every step. NSF brought together a coalition of partners to build and support the cutting-edge facility, instrument, and data management systems. More than 40 international organizations contributed to building Survey Telescope with the ability to gather more data than all other ground and space-based optical telescopes in history combined. NSF is proud to continue to lead Rubin's operations as it begins to deliver on its promise to expand our understanding of the universe. Thank you to DOE, our international partners in Chile, private donors like Charles Simoni, the National Academies for prioritizing Rubin in the 2010 Astronomy and Astrophysics Decadal Survey, and the entire Rubin team, especially Tony Tyson, Rubin LSST chief scientist who conceived and championed this project from the start. Vera Rubin is the namesake of this facility because she is the symbol of scientific excellence. Her legacy reshaped astrophysics and our understanding of dark matter. Generations of researchers have been and will continue to be inspired by her. Alan Rubin, one of Vera's children who's joining us here virtually today, once told NSF, Vera believed there is always more to be discovered. So let's keep discovering together and proving her right. Now I hand it off to Kathy Turner from the Department of Energy. Thank you.
Hello, everybody. We're incredibly thrilled to be here today for the unveiling of these new images from the groundbreaking NSF DOE Vera C. Rubin Observatory. Just a preview of the data to come. I'm Kathy Turner, Program Manager for Rubin Observatory from the Department of Energy Office of Science. Carrying out this project in partnership with NSF and the private and international partners has enabled us to bring all of our strengths to this amazing observatory. I am honored to work with all of them and look forward to our continued partnership. This observatory represents a giant leap in our ability to explore the cosmos and unwrap the mysteries of the universe. Of great interest also to the observatory's namesake, Dr. Rubin. Now I'd like to introduce Harriet Kung, our acting director of the Office of Science at Department of Energy. With decades of experience in scientific leadership, her vision and dedication have been instrumental in making this amazing observatory a reality. Please welcome Dr. Kung.
Good morning, everyone. Thank you, Kathy, for the wonderful introduction. On behalf of the U.S. Department of Energy, let me add my thanks to the long list of organizations that has made today's event possible. First of all, National Academies. I would especially like to single out the Board on Physics and Astronomy and also the Space Studies Board for hosting us in this beautiful auditorium today. I also want to thank White House OSTP, the National Science Foundation, and also the Association of Universities for Research in Astronomy, as well as my colleagues in DOE's Office of Science, for putting together the wonderful program that we'll witness today. But let me first introduce a short video from the Secretary of Energy, Chris Wright, who is not able to join us today, but he took the time during his recent visit to SLAC National Accelerator Laboratory to film the video you'll be seeing shortly. So let's cue the video.
Today we celebrate the culmination of 2 decades of scientific and technological innovation that have given us an ability to look into the cosmos, to understand our universe itself. This is the Vera Rubin telescope in Chile, and I want to congratulate all of those at the Department of Energy and the National Science Foundation, those working at SLAC out here in California, where I'm standing right now, and those on the ground in Chile, for this tremendous technological achievement that truly will bring an understanding of our universe simply not possible before. The movie has started, the camera is running, and we're going to see our cosmos unfold before us. Congrats to all.
Thank you, Secretary Wright. Having this event today really feels like a homecoming. It was really the 2010 National Academy's Decadal Study for Astronomy and Astrophysics that recommended that our high-energy physics program partner with NSF on what would become the Rubin Observatory, which was the number one top-ranked ground-based project. As Brian has already mentioned, the NSF DOE Vera C Rubin Observatory was a project long in the making with many moving parts. The DOE's Office of Science was proud to lead the construction of the LSST cam, the largest digital camera ever built. It is the size of a small car, but twice as heavy. The camera, boasting an impressive 3,200 megapixel resolution, was lovingly designed and fabricated by scientists and engineers at SLAC National Accelerator Laboratory, with critical contributions from DOE other national laboratories, as well as international partners. This camera, in conjunction with the Simone Survey Telescope, will create a 10-year survey of the sky in the Southern Hemisphere, known as the Legacy Surveys of Space and Time. This treasure trove of data set will give researchers unprecedented depth and clarity to questions that drive the fundamental research supported by DOE's Office of Science. And some of the questions include, how can we better understand the matter and energy that makes up 95% of our universe? And why is our universe ever expanding quickly, and how is that pattern change over time? And also, what role did dark matter play in how our universe evolved? We anticipate that the observatory will give us many insights into our past, our future, and possibly the fate of the universe. Answering these questions is a challenge that is matched with the many, many talents that contributed to today's success in the survey. We at DOE are extremely proud of the many people that have contributed to this amazing project. We're especially grateful for the indispensable cooperations from our international partners. In particular, the success of the Rubin Observatory relies on its location high atop Cerro Pichon in northern central Chile. That's why I'm so pleased to introduce to you His Excellency, the Ambassador of Chile to the United States. Ambassador Juan Gabriel Valdez has dedicated his career to fostering strong ties between our nations. Please join me in welcoming Ambassador Valdez. Thank you.
Good morning, everyone. Mr. Michael Kratsios, Director of the White House Office of Science and Technology Policy. Mrs. Harriet Kang, Acting Director of the Office of Science at the Department of Energy. Mr. Brian Stone, performing the duties of the Director of the National Science Foundation. Distinguished American and international authorities, esteemed scientists and friends of the National Academy of Science who welcome us today. I'm very happy to be here today. I have to say that I have received a number of calls from our friends, astronomers in Chile, saying that I had to be here today. Therefore, it's a fortune to be representing them this morning. Chile is without a doubt an astronomical nation. Evidence of astronomical observation by our earliest inhabitants dates back more than 2,000 years before Christ. Our geography gives us clear, dry, and stable, ideal skies for observing the stars. Astronomy is part of our identity and our heritage, and we are proud of it. But it is not only nature that has led us to become global leaders in astronomical observation. It is also the result of our government decision, a clear and sustained policy of international cooperation, scientific development, and the protection of our dark skies. Today we celebrate the first images from an extraordinary telescope, the Vera Rubin Observatory, equipped with the largest digital camera ever built for astronomy. But we also honor the memory of an extraordinary woman. Vera Rubin was not only a pioneer who uncovered key evidence of dark matter, she was also an inspiring example of integrity, perseverance, and humanity. Vera Rubin pushed the boundaries of scientific knowledge, but also her era. Naming this observatory after her is a profoundly symbolic and just act. It sends a message to new generations, and especially to the children and young people of Chile and the world, that knowledge has no gender and that the university is open to all. Vera Rubin has been the inspiration for the important and growing number of women astronomers we have in our country. For Chile, the observatories represent our commitment to knowledge, to sustainable development, to international cooperation, and to the defense of dark skies. The Vera Rubin Observatory is part of a unique ecosystem. Today, more than 40% of the world astronomical observation takes place in Chilean soil, and by 2030, that number will exceed 55%. This also places a great responsibility on us to protect our skies, to support science, and ensure that the knowledge generated here benefits all of humanity. Finally, I would like to thank everyone who made this project possible and who placed their trust in Chile as a strategic partner, the institutions of the United States government, especially the Department of Energy and the National Science Foundation, the international consortium led by Aura, the universities, engineers, technicians, and local communities that participate in this process, and to all who dream of uncovering the mysteries of the universe. We are delighted that the United States is looking at the universe from Chile. Thank you very much. I now invite Dr. Harriet Kang, the Acting Director of the Office of Sciences at the Department of Energy, to address us. Thank you very much.
It is now my distinct honor and privilege to introduce Michael Kratio, Director of the White House Office of Science and Technology Policy and Assistant to the President for Science and Technology. Director Kratio previously served as Chief Technology Officer of the United States during President Trump's first term, where he advised the President on landmark initiatives in artificial intelligence, 5G, quantum computing, and advanced manufacturing. Looking back, many of these initiatives not only had launched, but have continued to shape the trajectory of the nation's science and technology. Today, he continues to advise the President on emerging technologies and helps drive America's leadership in critical sectors vital to our national strength. Please join me in welcoming Director Kratio as we mark yet another milestone in America's golden age of science and technological greatness. Welcome, Dr. Kratio.
Good morning to everyone here and watching online. Thank you, Dr. Kung, for that introduction, and thank you all for joining us as we celebrate the completion of a monument to American leadership in fundamental science. The American people have always been animated by a spirit of exploration, and our national story is one of pioneers seeking new horizons and endless frontiers. It is fitting then that with the construction of the NSF DOE Vera C. Rubin Observatory, we will once again see further into space and deeper into time than ever before or anyone else. These first exquisite images made public today remind us of the full meaning of the words like awe and wonder and the limits of our language. They are sublime in their beauty, overwhelming in their scope, and profound in their promise of a discoveries to come. Like the majestic Hagia Sophia with its soaring golden dome and glowing mosaics, lifting the spirit towards the divine, the Rubin Observatory draws our eyes and our hearts upwards to the heavens. Long before Aristotle demonstrated that the earth was round, and even before Abraham looked up at the stars and saw the promise of God, humanity has peered into the skies in reverence, seeking to understand our place in the cosmos. We believe the work of this observatory will help us find long-sought answers and ask new and better questions. It will also provide the best map mankind has yet made of our region of the universe. From the Lewis and Clark expedition to the Voyager probe and the Hubble launch, America's greatest efforts into the unknown have been public goods supported by the far-sighted leaders in government. Some projects are just too big, too genuinely monumental for any other institution to take on. Only we, the people of the United States, can do it. In its primary mission, executing the legacy survey of space and time, the Rubin Observatory is a joint initiative of the National Science Foundation and the Department of Energy's Office of Science. It represents a whole-of-government effort, a magnificent partnership of the many components of the federal research ecosystem, demonstrating our shared work at its best. Let me extend my thanks to everyone whose efforts have brought us to this day, including Brian Stone, Harriet Kung, and Ambassador Valdez. We know that the best environment for truly groundbreaking basic research is collaborative and interdisciplinary. Thanks especially to the scientists of the National Science Foundation's National Optical Infrared Astronomy Research Laboratory, under the management of the Association of Universities for Research and Astronomy, and DOE's partners at the SLAC National Accelerator Laboratory. Each part of the national research enterprise has their role to play in this truly magnificent work. The telescope at the Rubin Observatory is a triumph of American technological ingenuity and skill. Its 27.5-foot mirror combines the primary and tertiary mirrors into one surface and was manufactured over the course of 7 years at the Richard F. Karras Mirror Lab at the University of Arizona. The 6,000-pound digital camera is the largest ever made, the size of a car, custom built by SLAC with a 3,200 megapixel CCD array and 9.6 square degree field of view. That means it could take a picture of 45 full moons at a resolution so high it will need a wall of 400 ultra high definition televisions to show it at full size. The 20 terabytes of data produced a day will be transferred to SLAC minute by minute for initial processing and distribution. With its unique mirrors, unrivaled camera, and trailblazing AI computing infrastructure, the observatory represents an investment by all of us in the future. Ours is a country of beginnings, of projects, of designs and expectations, too many of which have been borrowing from posterity for the comfort of the present. The project is, instead of a burden of debt, a gift to our children, one of which will lay down a cornerstone of knowledge and basic research today on which they will proudly build tomorrow. All of our most extraordinary technological advances and increases in our awareness have rested on new paradigms in fundamental science, as our brightest minds have groped closer to the truth of things and uncovered the mysteries of creation. In their knowledge of our ignorance, scientists like Vera C. Rubin have named two of those mysteries, dark matter and dark energy. And we all hope that with the help of the Rubin Observatory, these hidden cosmic neighbors will eventually uncover themselves to human science. In the meantime, I trust that the stunning images and staggering amount of data the observatory will produce will support exceptional scientific efforts around the world. The United States remains at the forefront of international science and technology research efforts, a leader whose partnership is always wanted. More importantly, even more than that, I hope the observatory and its work inspires America's children with awe and wonder at the grandeur of the cosmos and causes them to fall in love with the sciences and mathematics. So congratulations to everyone whose leadership and hard work made today possible. Your nation is proud of you and very proud of this observatory. And thank you all for joining us as we celebrate this achievement. And now, for the reason we are all actually here, let's see some of these amazing images.
You can plan, but sometimes things don't go as planned. We were hoping that Director Kratsios would show you first image. This observatory is the greatest astronomical discovery machine ever built. And we finally started working with it. This is the first image that we are unveiling to the whole world today. Thank you for your reaction. But now that we looked at this image, I have to reveal a fun fact. This image actually shows only a small portion of one Rubin image, just about 2%. In other words, the entire Rubin image is 50 times larger than what we are seeing here on the screen. So you may wonder, why didn't we show the entire image? Let us see why. Rubin Observatory, including its Simoni survey telescope in the middle, LSST camera on the left, and an exquisite software framework, is designed to make huge images rapidly. These three components you can see on the screen and their technological breakthroughs is what makes Rubin and LSST possible. Let us first have a quick look at the super agile Simoni survey telescope in the middle. You will notice the color scheme is matching everywhere, and indeed, my official Rubin tie is modeled after the telescope. Here you can see Simoni survey telescope inside the observatory's dome. The point of this short video is to demonstrate the amazing ability and agility of this 300-ton telescope. No other large telescope in the world can move this fast. It moves around in seconds. Other large telescopes take minutes. Let us now look quickly at the LSST camera. This big, beautiful camera is already in the Guinness Book of Records as the largest astronomical camera ever made. It makes huge images. As we just heard, just one Rubin image covers sky area equal to 45 full moons with its 3,200 megapixels. But that many pixels makes it very hard to display such an image. This is more pixels than the human eyes, your eyes, my eyes, can see. And this is the main reason why we could not show you the entire image right away, but only this small image shown in the bottom right. You can see its relative size to the full field of view in this small rectangle at the bottom. As Director Grazios pointed out, we would need 400 high-definition televisions to properly display just one Rubin image so that your eyes could capture all the detail. That means covering a basketball court with 400 TVs to display just one image so that your eyes can see all the detail. But instead of looking at 400 TV screens or walking around the basketball court, our team has developed a powerful web display tool that we can use to move around our giant images. We can zoom in and zoom out. We can explore and admire details of any object you choose to look at. Next, we will look at a region of sky about twice as large as one Rubin image. It is centered on the giant elliptical galaxy called Messier 49. This region that we'll explore in a second is about 100 times as large as the first image we saw today. The follow video is 1 minute long, and we will first enjoy it without any comments. Then we will replay it, and I will comment. Enjoy. We will look at it again. Before we start, I want to say that the entire Rubin team is so excited about this data. We have been talking about this data for over 2 decades. It's finally here. Let's look at it again. Please pause. You can see here a universe teeming with stars and galaxies. The seemingly empty black pockets of space between stars in the night sky, when you look at it with unaided eyes, are transformed here into these glittering tapestries. There is barely a pixel in this image that doesn't have some light coming out. And only Rubin can produce quickly such large images with this much color and richness. Please continue. Play. You can see spiral galaxies, elliptical galaxies, clusters of galaxies. Please pause here. This is an amazing region. We need to stop here. I love it. Do you love it? Yes. Everybody loves it. Here you can see a stunning variety of celestial objects, from bright stars in our galaxy, ranging in colors from blue to red, to these nearby blue spiral galaxies, to more distant elliptical galaxies that are yellow and red in color. You can see how vividly these colors are, and that's very important for science. Colors of galaxies are very important because using these colors, we estimate distances to these galaxies. You can also note in this image that galaxies are not randomly distributed in it, but they are clumped. They show clumping and statistical details of that clumping, and distances to these galaxies determined from LSST colors will enable very precise, unprecedentedly precise studies of the expansion history of the universe and studies of dark matter and dark energy. That's what we measure, where these galaxies are, how big they are, and what are their colors. And in few years, LSST will be producing unprecedented cosmological results. Let's continue. And now you can see the full extent of that image. It's about 2 LSST or Rubin fields of view. And this is how we scan the sky, 30 seconds per exposure. There were about 10 million galaxies, close to 10 million in that image. Thank you. This slide shows again the whole area that we just looked at the end of video, with the first image from today outlined in the top left corner, that small portion where your eyes could tell the detail. Known objects here are annotated with their names, and you may notice that most faint objects do not have their names shown, and that's because they have not been studied before. Most of these objects have never been seen by people before. As we already discussed it, in this projection, you simply cannot see all the details in this image because our human eyes and our screens are not good enough and large enough. There is so much more in this image that you can enjoy, that you could see in that 1-minute video. And you can actually do it yourself later at home using our tool that we developed for this purpose. All you need is internet, and at the end of the presentation, I'll give you a QR code with a link. And now I'm talking to our colleagues and friends on the internet watching us through YouTube. At the end of the presentation, you will get a link, and then you can spend the rest of your day enjoying these 10 million galaxies. We hope you enjoyed it, but there is more to show you today, much more. Imagine now an image like what we just looked at, but imagine it 1,000 times larger. That would be half of the sky, or the entire sky visible from Chile. That 1,000 times larger image than this giant image we just looked at, this is LSST, Rubin's main goal for the next 10 years. But LSST will be so much more than just an image, even though such great large image, it will be so much more than just an image. And that is because every object included in LSST, about 40 billion of them, for the first time more celestial objects than living people on Earth. Every object will be imaged about 800 times during these 10 years that it will take to deliver LSST. And that brings us to the greatest movie of all time, LSST. Because we will have 800 different observations, we can take these frames, we can put them in a movie, a digital color movie of the night sky. As I said, Rubin Observatory is the greatest astronomical discovery machine ever built. So let's see quickly what makes it so uniquely powerful. Most importantly, it can scan the sky super fast, about 10 to 100 times faster than any other large telescope. This is like comparing the speed of your car to the speed of an airplane. That's what we are doing. Instead of driving around from east to west coast for many days, we pop on a plane and we are there in 5 hours. That's what we are introducing here. It took us a few nights to collect data we are showcasing today. With existing facilities before Rubin, it would have taken at least a year and maybe more. And LSST would take 1,000 years, which is obviously impractical, not 10 years. This is why we had to build Rubin Observatory. And so let's talk now a little bit about movies. We have a couple of trailers to show you. So objects, we make movies of the night sky to see two things, objects that move and objects that change brightness. So objects that move come in two flavors. Stars in our galaxy move, and they move slow. We detect it, but it's slow. Much faster objects are asteroids, and they are in our solar system. And so we'll focus now on asteroids that we discovered in those few nights of data. So here nothing is moving yet. This is just to show you a tiny portion of that image that we will zoom in to discuss asteroids. Nothing is moving here either. What you can see is two spiral galaxies. What you cannot see is that these two beautiful galaxies were photobombed by asteroids. Let us see how. Here you can see asteroids as colored streaks. They are not satellites. They are asteroids that move during exposure. And this color image is made by combining many individual exposures. But asteroids, because they move, they disappear after you got one picture of them, one exposure. So these colors correspond to the principal colors used to construct color image. So you have red, you have green, you have blue. And so these asteroids, when we combine the image, we can remove them. Our software is smart enough to recognize them and remove the streaks when combining individual images. This is why you did not see them before. But now we will focus on asteroids. It's another 1-minute video. It showcases our unprecedented ability to detect small objects orbiting the sun. You can see motion against the static background of stars and galaxies. And we are only showing asteroids discovered by Rubin, not previously known asteroids. These are all new discoveries that were reported to the Minor Planet Center at Harvard this morning. There are so many of them. Just a few nights of data, just one tiny region on the sky. And now you will see their location in solar system. Let's pause here. So this blue donut, this is simulation of all the asteroids we expect there. And because we only spent few nights to get these data and we looked towards one small region on the sky, all of these new discoveries are found in this one narrow slice of this big donut. In 2 or 3 years, after we start LSST later this year, we will sweep around and discover all of these millions of asteroids. So we had 2,000 in these few nights of data. There are 7 near-Earth objects that have orbits that cross Earth's orbit. None of them is in such position to strike Earth, don't worry. We'll get tens of thousands more near-Earth objects. And we will discover about 5 million new asteroids during the next few years with LSST. This is 5 times more than all the astronomers in the world discovered during last 200 years since the discovery of the first asteroid. So because of this rapid development of technology today, we can outdo all these 2 centuries of effort in just a couple of years. Let us now see another illustration of the ever-changing night sky. We will look at objects that change their brightness. They don't move, but they change the way they look. We will look at stars that are called variable stars because they vary in brightness. They can change brightness on time scales from minutes to years. And by the end of LSST, we'll have data, we will know of about few 100 million variable stars. This is mind-boggling to people who work in this field. LSST will also discover a few million supernovae. Supernovae are exploding, dying stars that are very important for cosmology because it's relatively easy to estimate their distance. We will now take a detailed look at a few variable stars called RR Lyrae. They can become twice as bright in only few minutes, half an hour. That's why we chose them for this presentation. They are in reality about 50 times more luminous than our sun. And they change brightness because the whole star is pulsating like this on time scale of some hours. They are also very useful for studying dark matter in our galaxy because we can get their distances easily too. Here you see this blue star. It's blue because it's hotter than our sun. Our sun would look yellow in this image. And here we are comparing its brightness. Please pause here. So what you can see is color image of that star, average color image, and these two observations show its brightness in individual images. And the one in the middle is 30% brighter than the one on your right. It is hard to tell with your eyes, but it is very easily measurable in our high-quality images with our high-quality software that goes through those images. Let's continue. We'll see a few more RR Lyrae. The next example is even harder to tell with your eyes. It's only 11%. But again, for our powerful, precise software that looks at it, we know it's 11% and not 10 or 12. All these stars are found in our home galaxy, the Milky Way. It's easy to get their distance to distances much further than we can do today. And so over the next few years, we will map the distribution in the outskirts of our galaxy of both stars and dark matter more precisely than ever before. As you can see, the strength of Rubin and LSST is in huge images, in fast scanning of night sky, in discovery of huge samples of billions of celestial sources, and in studies of those sources with time, how they vary with time, do they move, do they change brightness? And that is the real purpose why we built Rubin Observatory. But there is one more thing to tell you today. As we look at the sky, we don't only collect huge samples, we make images of beautiful objects. And so today we want to share with you few beautiful objects, and we chose the Trifid and Lagoon nebulae. These nebulae are giant clouds of gas and dust, and they represent stellar nurseries. They are places in our galaxy where new baby stars are born by those clouds collapsing and becoming hotter and denser until you end up with a protostar, with a young star in the center. So this is the whole image. There are two nebulae. Top right is the Trifid Nebula. This pink nebula in the bottom is called the Lagoon Nebula. Again, this image is very large. It's about as large as the entire Rubin image. And your eyes and our screen are not good enough to display all the detail that we recorded in that region. Again, we will show through video that zooms in around all the vivid detail that is captured in that image. So, ready? Warp 1, engage. Wrong video. How did that happen? Peculiar. All right. We will have to leave that for later. So let me say a few words about what's next for us. That video, by the way, you can see when you follow the link from before, so nothing much is lost. You can enjoy it later. So we've just seen mesmerizing treasure trove of the stuff that LSST will start producing. We are getting to the close of the construction project. We are not done yet. We have some commissioning work to complete, some verification work to complete, but in a few months, we expect the project to be completed. We go into operations, and we will start this greatest digital movie of the night sky later this year, and it will go for 10 years. We did not talk today much about science, but I do want to mention over 2,000 LSST scientists who are eagerly awaiting the start of LSST survey. We want to thank them today, thank them for helping us to arrive to this point with their support and expertise. They helped us first build the science case for LSST that led to LSST being ranked #1 in NAS Decadal Survey in 2010, and they also are helping us to build Rubin Observatory. They are organized in 8 topical science collaborations, and they greatly benefit from the supporting nonprofit organization called LSST Discovery Alliance. It's formerly known as LSST Corporation, and that is the organization that started this project. But I also want to emphasize it is not just the scientists who will enjoy LSST data. It is everyone with curious mind interested in what's up there. Every child in school, we will have tools and materials that our education and public outreach team produced that you can use to be citizen scientists, that you can see in videos in planetaria, that if you're a teacher in high schools, it maps on your science curriculum. All of these will be available from that link QR code in this slide. And so now I will finally finish this brief presentation. The entire Rubin team, and let me add that I was greatly honored by our Rubin team to represent us today. The entire Rubin team hopes that you enjoyed this presentation. Please stay tuned for the exciting discoveries expected from LSST over the next 10 years and beyond. Thank you all here. Thank you all who are watching us over internet. Hundreds of locations in the US and Chile. Thank you and muchas gracias. Thank you to several hundred, close to 300 other locations around the globe. Hvala svima. And thank you for being with us today. And a big thank you to SLAC and Aura, our managing organizations. Heartfelt thank to our funding agencies, NSF and DOE, to our awesome program officers, Dr. Eda Jar, Dr. Kathy Turner, thank you, thank you, thank you. And finally, we are all very grateful to our host today, the US National Academies of Science. Thank you for having us. Greetings to all from the Rubin team. Thank you. This is for the Rubin team. Thank you, Rub. Thank you. We will now continue with our press conference. We will have a panel of Rubin experts that will be answering questions from our media representatives. So I would like our panel to come and join me on the stage, and then we will introduce them once they sit down. Okay, while you are getting on the stage, let's play this beautiful video. We start in the Trifid Nebula. We zoom out. You can see this. Now you can see the background composed of hundreds of thousands of stars. You can see beautiful colors that are due to light from stars bouncing off different types of gas, hydrogen, helium, and oxygen. You can see these dark spots. They are not holes in the sky. They are dark clouds that absorb light between stars behind them and us. They are in the middle. These are not holes in the sky. Here you can see a cluster of baby stars surrounded by this pink emission. These are all new stars that were born in the center. Again, more beautiful dust clouds. There are stars, just as many as outside the clouds, but that cloud blocks the light. And again, such a large image with so much detail, such vivid colors, to produce it in a reasonable amount of time, you really need Rubin Observatory. So if we could go to the last slide. Actually, I think I remember names of all of my colleagues. So let me start with Sandrine Thomas.
Afternoon, good evening, everyone, wherever you are. My name is Sandrine Thomas. I'm the Rubin Deputy Director and Telescope Scientist. And for the last 10 years, I've been honored to work with a very talented multinational team focusing on delivering the sharpest image quality that was possible and enabling the telescope to scan the entire southern sky in only a few nights with this exquisite image quality.
Thank you, Sandrine. Aaron Rudman.
Hello, I'm Aaron Rudman. I'm a professor at the SLAC National Accelerator Lab at Stanford University, and I've been honored to lead the team at SLAC that built the world's largest camera. I'm particularly excited about the discoveries that the Rubin Observatory will make, and particularly eagerly awaiting the light that we will shed on the nature of dark energy and dark matter.
Thank you. Victor Krabendam.
Good morning. My name is Victor Krabendam. I am the project manager for Rubin Observatory. I joined the project 21 years ago, but it's been my honor for the last 13 to be leading the project. The team that we represent here today is an incredible one. We have persevered, we've innovated, and we have overcome challenges. And right now, we envisioned that the project was going to be everything that we dreamed it would be. I look forward to delivering this project on budget and handing it over to the operations team later this calendar year. On behalf of all of the scientists, the engineers, the administrators, and the technicians, I want to thank both agencies and some early donors for trusting us with over $800 million to make this ambitious project a reality. Željko mentioned
Hvala na pažnji, to je zaista na momente bilo wow, verujem. Na početku smo možda imali dosta govorancije koja je svakako na neki način relevantna za nas na kraju, zato što smo imali prilike vidimo ove fantastične snimke. Napravili su teleskop da lovi tamnu materiju, on je prvi dan ulovio 2000 asteroida i sve ove snimke. Kao u svakom bioskopu, kad smo videli neke filmove, a tek ćemo gledati, na kraju tamo u Americi oni predstavljaju tim koji je radio na proizvodnji filma, a sad ja pozivam naš tim koji je učestvovao u ovome da ljudi koji su veći deo ovog spiska je tu večeras sa nama, da nam se pridruže ovde na sceni, da ih pozdravimo svi zajedno, jer oni su kao i ljudi u Americi takođe ravnopravno učestvovali u proizvodnji instrumenta koji je napravio one fantastične snimke. Hajmo astronomi, penjite se na binu. Moglo bi se reći, ovo je taj zvezdani trenutak. Izvolite, izvolite.
Ima nas više, treba vremena da izađemo.
Hajmo malo glasnije da pozdravimo heroje srpske astronomije koji su napravili Rubin Observatoriju. Dragana, izvoli.
Pa evo, ja bih zaista još jednom da se zahvalim pre svega celom timu. Ovo je samo jedan deo tima koji je mogao danas da se pridruži sa nama i nadamo se da će ova zajednica da raste, da bude još veća i da će, da kažemo, nauka u Srbiji zaista da pobedi zahvaljujući svim ovim vrhunskim istraživanjima kojim se mi bavimo. Izvoli, Luka, ako želiš nešto da kažeš.
Pa ništa, ja bih se zahvalio svima, posebno astronomskoj zajednici koja je onako mala, ali značajna. To smo videli sad i nadam se da ćemo u buduće uspeti da uradimo dosta interesantnih stvari, jer počelo je sad i treba na startu da radimo na tome da ta otkrića budu i naša i da naš teleskop radi na tome, ali i mi svi. Tako da su svi dobrodošli ko hoće da se priključi ne samo astronomiji, već čuli ste i građanska nauka i ljudi koji žele da istražuju vasionu imaće prilike da pogledaju ove snimke dubokog univerzuma. Hvala svima.
Dakle, ako ste uspeli da snimite one QR kodove, to je zgodno. Ako niste, prosto otiđite na sajt Rubin Opservatorije. Sve ove informacije su dostupne. Snimci, kao što ste videli, su vrlo bogati, a bit će ih još. Uživajte u lepotama astronomije. Hvala vam što ste bili večeras ovde sa nama u ovom vrlo specijalnom događaju koji pokazuje, između ostalog, da Beograd je vrlo zainteresovan za astronomiju. Biće ovakvih događaja još, bez sumnje, i umeđu vremenu, kao što smo rekli, nauka će pobediti.